Hi guys, we're going to do path sum. So we're given the root of a binary tree and an integer target sum, and they want us to return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum, and a leaf node is a node with no children. So if we take a look at the examples, we are given this example where our target sum is 22, and we would return true because we do have a path that would work, which is this blue path here. So if we add up the values of all of these nodes, then we have 5 plus 4, which is 9, and then plus 11 is 20, plus 2 is 22, which equals our target sum. So we return true. In example 2, we would return false because our target sum is 5, and there's no paths that would equal 5 for the sum. So if we do this path, then 1 plus 2 is 3, which is not 5. And if we do this path, we have 1 plus 3 is 4, which is also not 5. So there's no possible root to leaf paths that add up to 5, so we return false. In example 3, we're given an empty tree and a target sum of 0. And we output false because since the tree is empty, there's no root to leaf paths. So there's no nodes to add up the values of. So we just return false. So if we go back to the question, there's a few different parts that we'll need to keep track of here. And let's scroll down to the method definition they give us. So they give us the root and the target sum that we need to check if our nodes add up to that value. But we also need to keep track of a running sum of our nodes values that we've visited so far. So if we explore the tree, so first of all, we're going to want to do DFS. So we explore every path as deep as possible as we can before we go back and look at another path, because we're going to want to get the sum of the path, to check if that path sum equals our target sum. So for each path, we'll start at the root, right? And we'll go all the way down to this 7 here, and we'll check this target, or we'll check this sum, which would be 27, and that does not equal 22. So this one would return false, but then we just keep exploring the next ones. And so we'll know if it's a child node if node.left and node.right are both null. So then that's when we know that it's not a path anymore. So we'll go back to this one and go down here, and then this path will be 22 and will return true. So because we also need a running sum, which we don't have in this method definition, I'm going to create a helper method. So we're going to say private boolean, we'll just call it DFS because that's what we're doing, and then tree node, and we'll still have our target, and then we're also going to have a variable to keep track of the running sum, which I'll just call cur for current. And then we're going to return a DFS of our root, our target sum, and we'll pass in 0 as the starting sum value because when we haven't added anything yet, it's going to start at 0. So, okay, our base case here is if our node is null, which we have in example 3, right? Then this is an empty tree, so we're going to return false because there's nothing to add there. So if node is null, return false. Okay, and then same thing, like even in a tree that we do have nodes, this will also happen at the end of each path because, like, for example, in example 2, if we visit 1 and then 2, and then we want to keep going, right? So we check node.left, that's going to be null, so that would return false. Node.right is also null, so we would return false in that case because that's a leaf node. But anyways, so we'll do that for a empty tree, and then after that, so we want to add our running sum to our current node's value, right? So we're going to add, so we'll say current plus equals node.val. So if we're at this 5, then we're going to want to add 5 to our current sum, which is 0, and then we'll get 5, right? And then we're going to check if it's a leaf node, so we'll just keep doing that until we get down to the bottom. Let's say we're at 7. Then if both node.left and node.right are null, then we know it's a leaf node. So then that's the end of the path. So we're going to return if our running sum is equal to our target in that case. So if node.left is null and node.right is null, then we'll return whether or not the target equals our running sum. And then otherwise, that means we're not at the end of the path yet. We're still in the middle of the path somewhere. So we're going to return, and we're just going to perform a DFS on the left subtree and the right subtree. And we want to check if either the left or right subtree would have a sum that equals our target. So because it's either one, we're going to do node.left, our target, and our current running sum, and then we're going to say or because as long as we have one that works, then we're still going to return true. So then we'll also do a DFS on node.right, target, and current. And that should be it. Okay, and then let's pull that down so we can actually see. So our time complexity is O of n, where n is the number of nodes in the tree. Because, like worst case, if our sum that equals our target sum is all the way at the bottom right of the tree, then we're gonna visit every single node once, or exactly once, yeah. And then in our space complexity is also going to be O of n, because for the same reason. So if it's at the bottom right, then worst case, we're adding every single node onto our call stack. So that's it for this problem. Thank you guys for watching. Bye.